All right, so welcome back. Today we're going to be looking at traffic capacity and flow theory. We'll be going through a few different problems in the transportation section that I think is going to be very key for you as you're studying for this civil FE exam. So let's look at number one. It says, for a highway segment, the free flow speed is 60 miles per hour and the jam density is 160 vehicles per mile. Calculate the speed using the Green-Shields model when the density is 80 vehicles per mile. All right, so we want to start by saying or looking at what we're given. All right, so what is the information that we're given? Well, we know free flow speed is 60 miles per hour. We know that we have a jam density, and that is 160 vehicles per mile. And we know that the regular density is 80 vehicles per mile. All right. So that's all the information that we're given. And what are we trying to find? All right. Well, we're trying to find the speed. And we want to use Green-Shields model. All right, so let's do a search, right? Because I'm thinking we're probably going to need some formulas from the FE manual. So I'm just going to do a search in the FE manual for Green-Shield. If I can spell Green-Shields. I search. There's only two things that come up in the FE manual, and look at here. So, all right. So traffic flow relationships, and so based off the given information, we're looking for speed. Speed is, according to this, S. All right. So the formulas that I see that we can use is this top formula. S equals, and I'll zoom in so you all can see a little bit better. So S equals SF minus SF over DJ times D. So so basically now we just want to check to see if we have the variables that we need so that we can find the value that we need, right? So what is SF? The theoretical speed or free flow speed, right? We have SF, that is our 60, okay? And then DJ, DJ stands for jam density. We have that. And what about our other variable, which is D, which is the regular density that is in vehicles per mile. So we have everything that we need to solve this. So let's go ahead and solve it out. So S is equal to SF minus SF over DJ times D. All right. S is equal to 60 minus 60 over 160. I'm just plugging and chugging times 80. All right. So once you go through that, you should get S to equal 30 miles per hour, or C. All right, let's look at number two. All right. So it says in zone A, 30,000 trips are produced, and in zone B, 20,000 trips are attracted. The distance between them is 15 miles. The friction factor is 0.02, and the socioeconomic adjustment factor is 1.5. Calculate the number of trips between zone A and zone B using the gravity model. Okay, so what are we given? We are given the amount of trips produced, trips attracted, the distance, the friction factor, and the socio-economic adjustment factor. I'm going to call that SAF. And then we're asked to calculate the number of trips. So we're trying to find the number of trips using between zone A and zone B. I'm using the gravity model. So we know that we need to use gravity model to help us solve this. All right, so what are the formulas needed? I'm going to start by searching in my FE handbook, gravity model. And once I search that, something comes right up. So see, based on the information that we're given, right? If I'm trying to find the number of trips, which would be Tij, right? So what I'm trying to find, it looks like. We have Pi, okay, is the total number of trips produced. We have that information. So we have Pi, which is in this equation here. Okay, what about Aj, right? The number of trips attracted. We have the trips attracted, right? Which is the 20,000. What about Fij, friction factor? Between the two, we have the friction factor of 0.02. And then do we have Ki, socioeconomic adjustment factor? We do have that as well. And the bottom is just a sum of them multiplied together. So looks like we have everything we need to go ahead and start solving for this. I'm going to use a different color just for the fun of it. So let's start by writing this formula out. So, and I'll just write out my variables just to share this information with you. So in this case, the Pi, total number of trips produced in zone I, okay, would be 30,000. Okay, my AJ is equal to number of trips attracted, which is 20,000. Okay. My Fij is going to be my friction factor, which in this case is 0.02. And then the Kj, the Kij is equal to socioeconomic adjustment factor, which equals 1.5. All right, so let's solve. And I'm going to say Tj. And I'm just going to start plugging. Hopefully this makes sense. 30,000 times my Aj, which is 20,000, times 0.02 times 1.5 all over the sum. I can say the sum of Aj, 20,000, times Fij, 0.02, times what else? The 1.5. Right? Yes. All right, so when we look at all this, what you're gonna figure out that all this cancels out to just equal 1. So it's just gonna be 1 times your 30,000. So the total amount of the number of trips is gonna be your 30,000. And hopefully that made sense. All right, let's look at number 3. Right. This one says, how does the jam density impact the maximum flow when increased according to the green shields model? All right, so let's go back and let's first start with what information are we given? They're not given any variables, so I'm just going to say that's not applicable for this. What are we trying to find? Jam density impact. So how does the jam density impact the maximum flows when increased? So find what happens. This question is asked a little weird, but find what happens to the maximum flow when jam density is increased. All right. And are there any formulas that we need? Well, we're using green shields model. And so if you guys know it, can remember the formula, cool, but I cannot. So I'm gonna search in my handbook. Green shields. All right. Okay. Let's take a look at it. So we want to look at a formula that has maximum flow in it. So maximum flow is represented by Vm. Max flow is Vm. Okay. So what happens when jam density is increased? So we say Vm is equal to dj sf over 4. So saying that, I guess, theoretical speed, which is sf, if we leave that the same, and we say that if we increase our jam density, what happens to our max flow, right? So let's just look. Let's say we say Vm is equal to, I'm just going to plug in a number. I'm going to say 4 for DJ, and we'll say SF is 1 over 4. So that's going to give us 1, right? But so that was us using 4 for DJ, but let's say we use 8 for DJ. So we'll say Vm, and this is us increasing the jam density. So 8 times 1 over 4, it's keeping everything else the same. We get 2, right? So as our jam density increases, then our max flow should also increase. Hopefully that made some sense. All right. So that concludes this section for traffic capacity and flow theory. Hopefully this was helpful. And in the next video, we're going to start taking a look at traffic control devices.